So when we do a normal distribution, the first thing that we have to do is we have to convert that sum into the z-score. That's the first thing we have to do. So let's make a list. Z-score. So z-score formula is z is equals to x minus mu divided by sigma. Sigma is the standard deviation. So whenever we do a normal distribution sum, the first thing that we have to do is we have to convert the sum into z-score. So let's do a sum. So this normal distribution is given. I'm not giving any story or any unit. This is the random variable x, and it has a mean of 5 and the variance of 2 square, meaning 4, and we have to find the probability. Find the probability A, probability of x is less than 7, B, probability of x is greater than 10. Then let's make this, for convenience, let's make this greater than 9, greater than or equals to 9. Then we can have probability of x is less than 4. Then we can have probability of x is between 3 and 6. Okay, so let's do these 4 sums. So the first thing that needs to be remembered is when we do a probability sum, we have to do the z-score, because the question has a unit, although I didn't give any story behind it, but it would have a unit. So the first thing you write, therefore probability of z is less than 7. So 7 is x, so the z-score would be 7 minus mean is 5, divided by standard deviation is 2. That means probability of z is less than 7 minus 5 is 2, 2 divided by 2 is 1. So probability of z is less than 1. Now you remember that when we have to do a probability sum, we have to look up the table, because the table is the standard normal distribution, and for looking up the table it has to be a cumulative table, meaning it has to be less than and it has to be positive, so it matches. So let's look up the table. So here we have the table. Now we have to look up z is less than 1. So 1 means, this is 2 decimal places, so 1 means 1.00. So this is 1.00. Let me enlarge it. Okay, so 1.00 means z is less than 1, and the probability is 0.8413. 0.8413. So that is the probability. Now let's do the next one. The next one is probability of z is greater than or equals to 9. So the first thing we have to do is z-score. Z is greater than. Now one thing, since this is continuous distribution, so we don't have to bother with the equal to sign. So whenever you have an equal to sign in the question, just from the next line you don't have to write it, doesn't matter at all. So x minus mu divided by sigma, so x is 9 minus mu is 5, so the mean is 5, the sigma standard deviation is 2. So this is going to be probability of z is greater than 9 minus 5 is 4, 4 by 2 is 2. Now you have to understand this is not cumulative because it is greater than. This is a positive value, but in the table remember everything has to be cumulative, less than. So we need a special rule to convert this. Now standard normal table, the standard normal distribution table, it has to be cumulative. So z is less than a, it has to be in this format. Remember, z is less than a or less than equal to a is the same thing, so it has to be this format. So how can you convert it if it is not this format? So one is, if it is greater than, if it is z is greater than a, you can write 1 minus probability of z is less than a. This can be written, and one of the main reason is that because the normal distribution is symmetrical, that means one side and the other side, they're exactly the same. So for that reason we can actually write this. So So this can be written as 1 minus probability of z is less than 2. So now we can look up the table. So 1 minus probability of z is less than 2. So in the table, so 2 means 2.00. So we have it here. So z2 means z is less than 2.00. Remember, this is a cumulative table. So the probability is going to be 0.9772. 0.9772. So let's bring out the calculator. 1 minus 0.9772 is 0.0228. 0.0228. So this is the probability. You notice the z-score, the z values are in 2 decimal places and the probabilities are in 4 decimal places. So the next one, question number C, is probability of z is less than 4. So the z-score is going to be probability of z is less than 4 minus mu is 5 divided by 2. So it's obvious this is going to be negative. So z is less than 4 minus 5 is minus 1. Minus 1 by 2 is minus 0.5. So this is going to be negative. Now less than is alright. It is cumulative, but it is negative. Remember, the table is cumulative and it is positive values. So we have to convert this to positive. So another rule for symmetry is, if we have a negative value, for making it positive, all we do is we reverse the inequality and it becomes positive. Or if we have z is greater than negative value, we reverse the inequality and it becomes positive. So this is how it becomes, a negative value becomes positive, a negative value becomes positive. This is what happens. So if it is less than negative, it becomes greater than, and you write positive value. If it is greater than negative, if you write less than, it becomes positive value. So this is how it all becomes. So we can write probability of z is greater than 0.5. Now remember, now it is not cumulative anymore. For that reason we have to write 1 minus. So the first rule is, if it is greater than, we write 1 minus. So 1 minus probability of z is less than 0.5. So we can look up the table again. So 0.5 means 0.50. So this is 0.5. Remember, 2 decimal places. 0.5 means 0.50. So 0.50 is 0.6915. So 0.6915. So we have seen, when we find the probability, if it is already in the cumulative format, we just look up the table. If it is not in the cumulative format, if it is greater than, we write 1 minus, because of the way the bell shaped is symmetric. So and we look up the table, and if it is negative, we reverse the inequality sign and then it becomes positive, and then we can just look up the table. Now the final one is, we have to find the probability in between. So it has to be, find the probability between 3 and 6. So for finding the probability in between, so what we can do, let's do question number D here. We have to find the probability between 3 and 6. So therefore z-score is going to be 3 minus mu is 5 divided by standard deviation is 2. Z-score 6 minus mean is 5 divided by standard deviation is 2. So this is going to be 3 minus 5 is minus 2. Minus 2 by 2 is minus 1. And this is going to be 6 minus 5, 1. 1 by 2 is 0.5. So we have to find this. And what we have to do is, we need a new rule, because how do you find the area in between? So the new rule that we have to the rule of symmetry is, you have something in between z, a to b, then you take the next value, probability of z is less than a, minus, you take the, actually this is going to be b, and you take the previous value, probability of z is less than a, and that's it, you subtract it. So probability of z is between a and b, it means the next value, probability of z is less than b, minus the probability of z is less than a. Now let me elaborate a little bit how this is working, because you see, we are talking about area, and area is actually about geometry. When we have a shaded region, we are actually talking about geometry. So let me see what we are talking about. When we are saying that this is z is less than a, we are actually talking about, suppose when you have to find the random variable, when you think about the random variable, it can take on any value, right? It's a continuous random variable, it can take on any value. it can be very small. We denote very small by this lazy 8 symbol in math. You don't have to bother about this, you don't have to use it. So this is a very small number, very small number given by this negative lazy 8 symbol, infinity symbol, and a very large number, very large number. So when we are talking about numbers, any number in the world, and a continuous random variable can be any number in the world. So it can be a very small number anywhere in the world. We write it as minus infinity, just the negative lazy 8 symbol. That means a very small number, and it can be a very large number. So all the numbers in the world is in between. So if I say this is a and z is less than a, they're actually talking about if this is the normal distribution, this is the random variable z score. Remember, we have converted it to the z score, so this is 0. So if I say this is a, so this one is very small number, minus infinity. This is very large number, anywhere in between is a. So when I say z is less than a, we are talking about this probability. This is the shaded region, that is the area. Z is less than a. So when we talk about z is less than a, this is what it means. This means z is less than a. When I say z is greater than a, then I'm actually talking about this region. This is greater than a. So this is greater than a, and this is less than a. This region is less than a. So they're symmetric. You see, since this is one and the same, if we say the whole thing is 100% or 1, and if this area is something, then this area is automatically going to be equal to 1 minus probability of z is less than a, by that logic. So if this is what you have in the table, and if you want to know this area, you take the whole area 1, you remove this, and you get this area. That's the logic behind it, just geometry. This is the shaded region concept. That is how it is working. Similarly, if you're talking about a negative value, if you're talking about something negative, when you have this and this is 0, and what happens is that if you say it is less than minus a, so 0 behind 0 is minus a. So if it is less than minus a, it is this region. Now if this thing is probability of less than minus a, by symmetry, if there is an a here, it would exactly be the same, because this is bell shape. This is 0, mean mode median equal. This and this, they're exactly the same. So this would be greater than. So probability of z is greater than a. That's why we have this rule that when z is less than negative a, is the same as z is greater than a. That's what I meant when I said by the law of symmetry. This is all that means. So this thing and this thing is the same. Now the final one, in between. So when we say something is in between, so we have this very small number, minus infinity, very large number, plus infinity. We don't have to bother about that. So the standard normal distribution, this is mean is 0. So suppose this is from a to b. So suppose this is a and this is b. So this is the region. This is the region we are looking for. Now can we think of this like this? Probability of z is less than a is this. Now probability of z is less than b is this. Now just by the concept of an area of a geometry, this is the larger area and this is the smaller area. So this is probability of z is less than b, and this is a smaller area obviously because a is behind this. So this is probability of z is less than a. Now if you remove the smaller area from the larger area, so won't this region be left? Won't this be left? Because from here, if you remove this, only this thing would be removed. So that's why we can actually write it down as probability z is less than b, the larger area, minus probability of z is less than a, the smaller area. So these are all done by symmetry and the concept of geometry. So that's all it is happening. So we are actually flipping the picture this way and that way and changing it, but if you just remember the rules, the basic rules, you can just do it straightforward. So this one means the next one. So probability of z is less than 0.5 minus probability of z is less than -1. So we know that probability of z is less than 0.5 is from this table 0.6915 minus, now probability of z is less than -1, by symmetry we can just write probability of z is greater than, and this will become positive. So 0.6915 minus 1 minus probability of z is less than 1, so 0.69. so we can just think, without even thinking about it, we can just directly do this geometric concept here. So z is less than 1, we can look up the table. So 1 means z is less than or equal 1.00, 1 means 1.00, 8413, 0.8413. So if we now remove the bracket, it will be 0.6915 minus 1 minus plus 0.8413. So this would be equals to, by using the calculator, 0.6915 minus 1 plus 0.8413, and this would be 0.5328. So this will be the probability. One thing that I can notice here, if z is less than or less than 0.5 is 0.6915, we have to do 1 minus here. So this time it's not done yet completely, so this should be 1 minus 0.6915. This is going to be 0.3085, so 0.3085. Yep, that's the idea. So now, so this is how we find the probability, and this is how we do the sum. But you have to understand, we are doing this for the exam because we are handicapped. We don't have any computer or software or anything. We just do the sum straight away using a standard normal distribution. But if you were given access to a computer, you do not have to go through the standard normal distribution. You can directly, using the software, find this. So let's try to do this. Let's try to do where we have a normal distribution with mu equals to 5 and standard deviation 2, so variance is 2 square, meaning 4. So let's try to find let's do this one first. So between 3 to 6. So let's use the software here. So this is 5 and this one is going to be 2, so the variance is 4. So now we have to find the probability between let me check. So we have to find the probability between 3 to 6. Okay, so this will be 3 and this will be 6. Now notice we got the probability as 53.3%. that means if you divide it by 100, 0.533. so you see, we don't have to convert it to z-score. We directly, using the calculator, we found it. So our answer was, we just did this, 0.533. if you take 3 decimal places, 0.533. so this is exactly what we found. So you don't have to use the z-score when you actually do it using the software, but in your exam you have to do it. So let's check the next one now. Let's check question number C, where we have z is less than 4. Now when you have z is less than 4, what does it really mean here? Between what? Well, it means between the first value, a very very small number. Let me take here in the software, for this particular software, minus 100 and 4. So less than 4 means from the beginning. Let me call the beginning, since here we have something very smaller than that. So less than 4 can be written like this. It is 30.9%, meaning 0.309 if you divide by 100. So we have 0.309, so it matches. So 30.9% is this one. Okay, now question number B, greater than or equal to 9. Same thing as greater than 9. So let's check greater than 9 in the software. So greater than 9 means we start from 9. Okay, so greater than or equals to 9 means in the software we have to put 9 here, and large value is 100 is good enough. So it is 2.3%. 2.3% means 2.023, so something like that. So let's check question number B, that is greater than or equals to 9 is 0.0228. It's alright, 0.023. So that's also correct. Let's move on to the first question, where is that is less than 7. So here in less than 7, this software, so it starts from the very small number and ends at 7, less than 7. So that probability is 84.1%. that means 0.841. so let's check back again. Has to be something to 0.841. Absolutely correct. So using the software, different software works differently. You input the values differently. That's not important how you input the value, but the main thing is, in reality, you can just use the software and the sum would be done. So all you have to remember is, when we do the sum, we are doing the sum because of a handicap, because we have a table. That table is a standard normal distribution. We have to convert the regular sum into a sum where we have no unit at all, and then we have to look up the table in a special way by the law of symmetry, because the table is a cumulative table and it has all positive values of z. So that's the reason we have to go through the trouble of doing the sum in the way we are doing. So the next one will do a special type of normal distribution sum where we don't have to find the probability. The probability will be given. All we have to do is we have to find the mean or the standard deviation.